Definitely. All right. So section 1, 2, number
73.
73? Yeah. Oh, okay, beautiful. Perfect. I almost don't want to do that. In fact, I won't. Do you have a specific question on one of them, or is it just the whole thing?
Just the whole thing.
All right. So part of what I'm going to do today is I've got from an old textbook I used to use examples of that. That's the only little area where they have like a pick out the sampling method question in the book, so I don't want to do too much of that. So I want you guys to try it out. So we'll do this later, and hopefully we'll see if it clears up questions on that. All right. Any other questions from homework? A valid question would be, how the hell does homework work? Well, hopefully everybody's understanding. If you don't have a textbook, you can access it online. You can do the homework out of there. Cool. Anybody got a physical textbook?
Just ordered mine.
All right, sweet. You got yours coming?
Yeah, I ordered mine too.
All right, good. Sweet. And you don't have to. You can get it if you want to. $35 or something, right?
Yeah.
All right. If you paid more than that, you've been ripped off. You should argue about that with whoever made money off of you. Okay. So nothing else from chapter 1? Or what we've done so far? All right. So let's close out chapter 1 real quick. Nowhere near enough definitions yet, right? So let's add in some more. You can always have more definitions. So we're sort of in section, let's see, 1.3 now. Believe it or not. Blah, 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 blah. Yeah, let me make sure I didn't pick any. Cool. Oh yeah, we'll get there. Okay. So the main two ways to break up types of data were quantitative and qualitative, right? And then we saw one way to break up quantitative was with two subdivisions, and what were those? Discrete and continuous. Kick-ass. All right, hopefully those should make sense. Now, we'll see. I've got a little review we can do. And then here's 4 more levels of variables. And really, every level of a variable describes what you're able to do with the data from those variables. So, for example, we talked the other day about you can't really, could I get an average hair color in here? That would be extremely strange, right? Because I have to add the hair color. So what's brown plus blonde? Right? Brown blonde. I don't know what that is. Right? You with me? You can't add it, so how can you get an average if you can't add them and divide? What the hell? So data that's just like characteristic data, this is almost like the qualitative level, is called nominal. If I say, let's see who's my horror book readers out there. If I say the name Richard Bachman, does anyone know who that actually is? Anybody like Stephen King? Mm-hmm. So Stephen King's plume de nom, his pen name was Richard Bachman. And actually some of those books are really, really good, to be honest. If you don't like Stephen King, well, fine, somebody else. So sometimes when you write a book, you'll have a different name than what your name actually is, for various reasons. So that root word is nom. So this is data that's just names. So this is name data. All right, so that variable would have outputs that are just names. So obviously, hair color. Right, so some examples of this would be hair color, type of car you drive, we talked the other day about something that seems like it might be quantitative, but it isn't. Jersey number, right? Social security number. Okay, cool. Stuff like that. So that's pretty simple so far. So that's the most basic level of data. You can't do much with that except maybe calculate percentages. I can talk about the percentage of people in here who have blonde hair, right? I can do that. You kind of with me? So, but that's really almost all you can do with it. And you can make bar graphs and pie charts and show the percentages. You guys kind of with me? So there's not much I can do. The second level data is not even that much further above that. But the second level of data is name data that have an inherent order. So thankfully they're called ordinal. That's kind of nice. Everyone has like a little giveaway as to what the hell it is. This is ordinal data. So ordinal data is name data. So if you came in 7th in a race, that actually is sort of like a name. Where's that guy that came in 7th place? That's your name, right? But obviously, first place, second place, third place, there's an inherent order to them. So now notice, could I put cars in alphabetical order? Do they have to be in alphabetical order? No. You with me? But if I lined up people that were in the race and I put, okay, 5th place, you stand first, and 28th place, you're second, and 17th place, you're like, what are you doing? There's an inherent order. First, second, third, please, dear God, man. The order of the universe. You with me? So just because you could put something in some kind of order doesn't mean it's ordinal. Ordinal, when it has to be in this order to make sense. So another example, so this is a name data that has inherent vice. No, order. No inherent vice. Okay. Inherent order. So for example, it could be the place in a race. First, second, third. It could be when you go to a restaurant, and sometimes they have a little card on the table, and they say, "Tell us how we did." And if on the card it said, "Did we do good, excellent, fair, or poor?" What's wrong with that? It's not in order. See, there's an inherent order that it should be in. You're like, you're trying to screw me up. You're trying to do a Florida hanging Chad shit on me, right? Or this guy is here and this guy is here. I don't know if you guys remember that. You're probably too young. You couldn't go back then anyway. It's too bad. You missed that on some exciting shit. Like, who is our president? We do not know. So it could be ranking of service, right? There's an inherent order to that. When you guys do evaluations, it goes from 1 to 6 or whatever the hell it is. Strongly disagree, neutral, agree, strongly agree, right? If they put that out of order, you would be like, are you trying to mess me up? Are you trying to screw me over? Yeah. Right? You would be upset if it wasn't in the right order. It's supposed to be in order. All right. That's
so would like military level be?
Yeah, exactly. Yeah, you could. That would have an order to it. I love it. So if I said BMW, Hyundai, Chevy, you wouldn't go, wait, that's not in order. There's no freaking order that needs to be in, right? But there would be an order to the hierarchy of military rankings. That's another kind of ranking. I like it. Cool. How are we doing so far? We're okay? Let me do, so these two are sort of mostly thought of as qualitative. Does that make sense? I mean, these are more name data. There are some examples there's sort of not a fine line, not a perfect line between them, but it's pretty much that's qualitative data. The next two are going to be quantitative in nature for sure. Oh, there's too many T's. Quantitative. No, that's good. It's like the word banana. So let me just put both of these up here because we need to talk about both of them at the same time to figure out what the hell the difference is. This one is interval data. Good. And ratio data. So once we get, what tells me that it's quantitative data? What would tell me that I have quantitative data? And what does that mean? I mean, these are numbers.
Numbers that can be added are
Beautiful. I can actually do computation with them. So, and it makes sense. Jersey numbers, I can add them all day, but it doesn't make a damn bit of sense. Unless, of course, you have the situation I was in with the basketball players. But it shouldn't, in general, it wouldn't make sense to add those together. So, interval means it's truly numerical, but what I can do with it is I can subtract data values, and it makes sense. Subtraction makes sense. And why does that, the name here actually does make sense for that. An interval of time, how would you define an interval of time? Like, over the last 10 years. You with me? So that would mean from 2015 back to what? 2005. Good. And the difference of those is the interval that I just said, 10 years. You with me? That's why the word interval actually makes sense with the subtraction idea, right? So this is data that can be, I got to be really careful. Data that, when subtracted, the answer I get makes sense. If I just say that can be subtracted, well, you can subtract Jersey numbers, but the answer has to actually make physical sense. Right? So if I was born in 1972, which I was, so I missed out on, I was too young to understand disco, thankfully. Right? Just see it in movies and shit. And you were born when?
1993.
1993. All right, I don't feel old at all. The difference between those 2 years would make physical sense. 1993 minus 1972 is 21. There's like a whole legal person between us. But does 21 make physical sense?
Yes.
Yes, that means 21 years apart. I was born 21 years before you were. There's a physical meaning to that. But if I subtract 2 zip codes, do you get a number? Yes. Does it make physical sense or some kind of sense at all? No, it doesn't make shit worth of sense, right? You guys see the difference there. So don't just tell me, yeah, I can subtract it. No, the subtraction has to make some kind of sense. So that's a good example would be year of birth. Now before I give you more examples, I need to go to this, what ratio is. Because one thing I want you to realize, every interval data, do years have an order to them?
Yes.
Yes, that's crazy. So they're also ordinal. Are years names? Yes. Yes. What happened back in 1972? That's the name of that year, right? So every one of these is this, which is also this. So when I ask you what level of data is this, don't say everything's nominal because everything is a name of something. No, you tell me the highest level of data that it is. Because that tells me what's the most I can do with this data. Data here, can I subtract them? No. But data here, I can't. So it tells me how much I can do with my data. How are we doing so far? You all right? I love it. You guys have different emotions. At least there's emotions today. I think last time was all poker face. Okay. What do you think you can do with ratio, considering the word ratio?
Ration.
You can divide, right? So division makes sense. And there's also one other thing. This is interesting. These kind of go hand in hand. Division makes sense because 0 means what it's supposed to.
No.
There's an inherent 0. So let me show you why I've got to put both of these definitions up here. How many different temperature scales do you guys know?
3.
Good. Some of you know 3. Some of you guys are like 3, right? So there's Fahrenheit, Celsius, and then Kelvin, right? So we're not going to talk too much about Kelvin because not all of us know Kelvin. This is true. Yeah, so Kelvin actually measures heat. So when you reach 0 Kelvin, that's what's known as absolute zero. So there's some horror movies that are really stupid. They talk about absolute zero. I was doing research back on the East Coast about bringing rubidium atoms down to almost absolute zero, and they all kind of glorb together, bloop, 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 and you can poke it. Bloop, bloop. That was really what I was doing. So Kelvin would go here with Fahrenheit, what Americans use, because Americans, of course, we're different from anybody else. And it makes sense, right? I mean, it makes total sense. What's the freezing point of water in Fahrenheit? 32. Yeah. 0. Ooh, 0. Yeah, that does make sense. Shit. Right. That would be Celsius. Yes, sir.
Forgive me for taking off on a tangent here, but Fahrenheit 0 point is in fact set at a sensible area. It's just set at the freezing point of salt water.
Exactly.
Which
Cool. I like
doesn't
it.
do us a lot.
So there's other things about triple point of water and all that kind of other considerations. But Celsius is the one that's kind of based on a metric system, right?
Yes.
Because what's the boiling point of water in Fahrenheit? Do you guys know? 212. And what's the boiling point of water in Celsius? 100. Right? Cool. So as long as we kind of know inherently what the hell it means, so we can interpret that thermometer that we're looking at, the thermostat, then we're fine. Right? But both of those, Celsius and Fahrenheit, the 0 degrees mean the absence of what it's measuring. Meaning, if you hit 0 degrees Fahrenheit, can you not get colder? Can you get colder than 0 degrees?
Yes.
Yes. I know we live in San Diego, and we're not, does 0 exist on there? Yeah. But if you lived up in Minnesota, and you're up there, and it's like -40, and you're like, oh, this is warmer than yesterday. Right? It's not good. You go out ice fishing, whatever the hell you have to do to keep yourself sane. Sorry, I'm sure it's beautiful. So example here, so far, is Kelvin, which we don't all know. So let's come up with a better example there. More examples here would be like Fahrenheit and Celsius temperatures. Because 0 doesn't mean what it's supposed to mean. And you can see why. What's twice as hot as 0 degrees? Not 0 degrees. That doesn't make any sense. Twice as hot as 0, I don't know, 10 degrees or something. What's twice as hot as 60 degrees? I wouldn't say 120. Like if I said it's twice as hot today as it is yesterday, and yesterday was 60, it wouldn't have to be 120 for me to say that. Do you guys see what I'm saying? So that division doesn't make any sense because 0 is in the wrong place. Technically, it's not the absence of what it's measuring. Does that make sense? All right, maybe. Can somebody give me another ratio, something that would actually work? A 0 means what it's supposed to mean, and division makes sense. Maybe something related to this. That's the year of birth. Age. What does 0 years old means? I like that. What does it mean? You are not on this earth yet. We're not going to get into a whole philosophical discussion about when does life begin. Let's not do that shit. But let's say before you are out. I don't know why I just had to do a visual. You guys know how babies are born. They come out. They squirt out. That's how it happened for me. I went flying across the floor. Before you're out, let's say you're not even existing. So the 0 means you haven't come out into the world yet. Right? You're still either not created or you're not around anywhere, right? So 0 means what it's supposed to mean for age. And if I'm 42 and you're 21, then I am twice. 42 divided by 21 makes physical sense, right? You wouldn't say divide 2 zip codes and this zip code is twice that one. It doesn't make any damn sense. So age goes here. Can we make this more general? What else would be ratio data? Yeah, actually, yes. So discrete and continuous don't actually fall anywhere definite here. So the number of shoes you own. If you own 12 shoes and I own 4 shoes, you own 3 times as many shoes, right? Or if you saw 8 turtles and I saw 2 turtles, you saw 4 times as many turtles. It makes physical sense. You guys with me? And that's all discrete data, but that discrete and continuous is not a part of this at all. They just fall wherever they fall. How are we doing so far? But in general, age, the number of turtles I saw, the number of shoes I own, they're all what? The number of words I can type, how tall I am, how much I weigh, they're all measurements. So most measurements would go here. These measure temperature, so why are these not here? Because they're freaky measurements. They are measurements where 0 is in the wrong damn place. That's why they don't go there.
Would money be one?
In what sense?
Like
So
how much you have or like how much you don't?
yes, exactly. So if you got $20 and I got 10, you got twice as much of me. I love it. So amount of fill in the blank, just about everything that you can fill in the blank there would be ratio. Notice how I'm covering my ass. Not quite everything, I don't know at the moment, but basically almost everything you say amount of fill in the blank. Cool. What about profit? That's sort of like what you're saying. Profit, could you have negative profit? Yes. So where would it go? Does that, I might have thrown you off. Maybe that question doesn't mean shit. Where would profit go?
Go to.
See, I did throw you guys off.
Maybe ratio,
It's ratio. What does 0 profit mean?
No.
Absence of profit. 0 means what it's supposed to mean. If I made $2,000 last year and $4,000 this year, sure enough, I made twice as much. 4,000 divided by 2,000 makes physical sense, right? So profit, just because it's got negative values, 0 is in the right place. So it's not because this has negative values, it's because 0 is not in the right place. 0 doesn't mean the absence of heat. 0 just means it's that cold, and then you can get colder. Do you guys follow? So it's not the negative thing, it's because 0 is in the wrong place. That's why that was up here. Okay, maybe. Yes, sir.
Now, correct me if I'm wrong, but it's basically a way of saying that a 0 is an absolute in this sense.
Yes, it's not. It doesn't mean the absence of what I'm measuring. Exactly. Cool. I like it. Okay. All right. So before I finish out, there is a little bit, it's kind of an overlap between section 1.3 and chapter 2. And I'm actually going to be real evil and just let you guys read section 1.4 on your own, just because I want you to have access to the book for a reason. I want to do this real quick before we get too far away. This is a little review of all the words we've learned and what the hell they mean. It will be in a second. Well, real quick, while I have this up here, this is Gallup.com, and it's got, they do all kinds of stuff. They have, they keep track of what the approval rating is of our president, what percentage of people are engaged at work. That does not mean that you propose to somebody, but just that you're into your work. The unemployed figure, of course, has gotten a lot better here over time. Become a graph. Become a graph. All right, don't. You just do what you want to. But this, I wanted to show you this because I like it. Oh, there it is. You only go back to February 2010, but of course, for a while there, it was like, hello, shit. Okay, now we're back to normal almost. But what I really want to show you, this is an interesting little article on its own. So they asked people, what do you think is the value of a community college education and a 4-year college education? And what's nice for us community college people is they came out to be about the same favorability. This is for internet-based college programs, which I still am not a believer in. And then they should have put for-profit schools. Stay the hell away from for-profit schools, my God, if you are a smart person. If you're not a smart person, then you will learn through that experience that that's bad, and you'll become a little smarter. So don't do that. And then they broke it out by education level and age. What's interesting is the people that think 4-year colleges are good goes down as you get older, but for community, it goes up as you get older. So you're like, this is exploratory statistics. Why is that true? You can design an experiment that focuses on that to figure out why that's true. You guys kind of with me? So sometimes you just go out, I don't have a clue. So let's just look at what the hell's going on. And they go, that's weird. Let's focus on that, and they can experiment for that. That's how a lot of statistics works. But here's the thing. At the very bottom, they talk about survey methods. So they took a random sample of 1,527 adults, and this is supposed to represent what?
The United States.
The United States, right? So all they did was 1,500 people. Plenty. That's over plenty. That's plenty of people to do. And then here's some stuff. I like how they get a little bit into, and of course if you click here, they'll really get into their methodology. But notice how, a couple things. Results based on the total sample of national, it's the margin of errors plus or minus 3 percentage points. Right? So for everything up here, see how this is 75%? So it could be 72 to 78. Like it's somewhere in there. Right? And that's nobody's fault, it's just the nature of the beast. They didn't talk to everybody, so this is really, on some level, just a guess. It's a pretty good guess. And then they get down here about, there must be a minimum quota of 50% cell phone and 50% landline, and other quotas by time zone and regions, so that they don't over-represent anybody accidentally. Do you guys see? So if they take a random sample and they just happen to get everybody, then their sample is from the East Coast, that might be biased. So they actually build in that they take, so they kind of, what kind of sampling would that be then if they take a certain percentage of people from every time zone? Who remembers? Stratified, kick ass. Some from each is stratified. So they kind of are talking about setting up a stratified sampling method. I want you to realize that Gallup is a respected polling institution, and we've already learned a really good amount of statistics, and here it is being used in the real frickin' world. I mean, that's awesome. I can't always do that with algebra, for example, right? It's really sometimes hard because this algebra is just not high enough level to really live in the real world, so it's really hard to get there. All right. So let's do this. There we go. Cool. Just focus on one section at a second time. Wow. Okay. Blah, blah, blah. Let's do this here. Here we go. Determine whether this is a statistic or a parameter. So, look at the first one. In a AAA Foundation for Traffic Safety survey, 21% of the respondents said that they recently texted or emailed while driving. Why is it a statistic?
That's not a survey.
Yeah, of those surveyed. So that describes a sample. That's why it is a statistic, Kick-ass. There are 50 state capitals in the U.S.
Parameter.
Yeah, because that describes the population, right? There's no other, we haven't gone and conquered anybody else. Thankfully, I think that period's over. Well, Russia goes, hey, wait a minute. Sorry, if you're Russian, I apologize. Putin's like, where else? Oh, I like the Ukraine, but where else can I? Titanic, a study was conducted of all 3 passengers aboard the Titanic when it sank. Yeah, why parameter?
Because they're all.
It says all. Yeah, that key word all means that they didn't leave anybody out, so they looked at the population. Among the flights included in the sample of flights in dataset 15 of Appendix B, 21% arrived late. Exactly, so that's enough of those. Parameter and statistic are really pretty simple. Are they talking about the sample, just the people they talk to, or whatever? Or are they talking about the whole damn population? PPSS, that's awesome. Right? All right, so what about discrete continuous? Let's see. In data set 13, blah, 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 the measured chest deceleration of a Honda Civic in a crash test is 39 G, where G is a force of gravity. I like it. So is that a discrete or continuous set of data? So remember, the number 39 has not got a damn thing to do with the answer here. It's a measurement of G-force, right? And G-force is not just a cool old anime, no, or a stupid freaking hamster movie from recently that got me all excited when I heard about it. Like, shit, it's hamsters. That sounds right there. But it's, it's a measurement of how many, we all experience force of gravity. So if it was 2G, it would be twice the force of gravity, right? Pilots go around in that thing, 4G, 5G. Some Gs you pass out because your brain just can't take it. But couldn't it be 39.0463 G?
Yes.
Of course. That's what you don't look at the number they give you. Say, could it have been 8.298? Would that make sense? Yes. Okay. Then it's continuous data. All right. Maybe. Because it could be 1.5 times the force of gravity. It could be 1.439629 times the force of gravity. So that is definitely continuous. The Honda Civic has 4 cylinders.
Discrete.
Totally, right? I don't care how crappy your car is, how much banged up it got. It doesn't have 2.98 cylinders. Like, one of them doesn't quite work. No. Either it's a cylinder or it ain't. Word count. From blah blah, we see that a male spoke 13,825 words in one day.
Discrete.
Totally discrete, right? I don't care how much you don't like a word, it's still a word. You wouldn't say that's 0.7 a word. Anyway, so I think that's plenty. All right, what about, here we go. Now, here's the most recent, here's the stuff we just learned today. So I'm not going to, I want you guys, can everybody read that?
Yes.
All right, so do 21 through 26. When they reference appendices, don't worry about it. You don't need to see this list of numbers. You can tell me what the answer is anyway. Alright. This pretty much is you know it or you don't situation. So let's see. So we're talking about nominal, ordinal, interval, ratio, level, colors of M&Ms.
No.
Yeah, there's no order. Even if you like red the best, it doesn't have to come first. Depths of earthquakes. So I agree, you can subtract them and it would make sense, but is that all you can do? So, and what would 0 mean? How deep is that? 0, not deep at all, be right on the surface. So it means what it's supposed to mean. And if it was 10 kilometers deep versus 5 kilometers deep, that would be twice as deep, the first one, right? So that is what level then? Ratio. So to answer these questions, you almost have to give yourself a couple of possible values. Well, it could have been 10 and 5, right? Does that make sense? So if you thought it was interval, because you can subtract, it's true, but you can do more. You always got to go as high as you can.
So when 0 has a meaning, it's a ratio?
Beautiful. When 0 means what it's supposed to mean, it's ratio. Years in which presidents were inaugurated.
And that's going to be order.
So there's definitely an order to them. But basically any year of anything, right? Because you could take the difference and see how long it was between two presidents being inaugurated. You with me? So the difference does make physical sense. If the thing you're looking at is quantitative, years are quantitative, then it's got to be one of these two. So the first thing you can do is separate it, look at it and go, is it one of these two or one of these two? And then you can focus on figuring out which one it is. You with me? Because either it's a number or it ain't. Okay. Either you're with us or against us.
I said that last night.
What's that?
I said that last night.
Oh, really?
Yeah.
Oh, boy.
Talking with my homies.
Oh, okay. I was going to say, I don't know if I want to know all the details. The movie Avatar was given a rating of 4 stars on a scale of 5. I like this question.
Ordinal?
All right. Anybody have a different idea?
Could be interval as well.
Yeah, you could argue interval. And actually, I'm glad this question's in there because on a quiz, I actually always ask you for these kind of questions, tell me what level and explain. Because depending on the way you kind of look at it, I'll take possibly a couple of different answers. So in this case, ordinal I would completely take, that's fine, because that's a ranking. But interval could possibly work, but, you know, and the reason why I take both is you're like, well, they're stars, right? But interval, I understand, you could say 5 stars minus 4 stars is 1 star, so they're like 1 star apart. But does that actually make physical sense? Not entirely, but I would still kind of be lenient on that, right? So it's more like a visual. So I would lean towards ordinal, but if you said interval and explained yourself, I'd probably give you credit. Volumes of brains. Yeah, because volume is a measurement, and almost all measurements will be ratio. Not all of them, but almost all of them. Car model. Nominal, total.
I love it. All right, not too bad, right? All right, okay.
Yesterday, did we do 1.1 and 1.2?
Yes.
Yesterday we covered.
We did, yes.
Can you say 26 could be ordinal because it's used for crash testing, so you can see which one was better in the safety?
What's the data? What's the data? The names of the cars. If the data was the results of the crash testing, then we could start to say what that would be. But in this case, the data is that. In fact, I'm glad you said that too, because I never try to be evil, but sometimes I forget to say this, and then I put it on a quiz, and people freak out. Let me see what you think about this. If I said 13% of people were bald. This could be kind of an evil question. What level of data would that represent? And let me ask you this. In order to be able to say this, what data would I be looking at?
Qualitative.
Yeah, what would actually be on the list? I'm like, you have brown hair.
Like categories.
You are bald. Huh?
Categories.
Yes. The data are the hair colors. What is this? That's something I did with the data. I grouped them up and I counted how many were bald and I divided by the total to make 13%. But what is my data? Bald. Types of color of hair, right? So what level of data is that then? Nominal. Don't focus on this. That's a number. Yay, it is. But my data is that. So this would be nominal data. So I'll do that sometimes, and people focus on the percent. They say, well, you put percentages in order. That's great, but my data is hair color.
Yeah, 13 has me real good.
Exactly, yeah. But that percentage is always what I did with the data. That's not the actual data itself. Cool. I like it. Oh, did I have... No, I didn't have... Shoot. Oh, too bad for me. So I do have to go back to your question because I didn't have... I thought I had that on there, but I guess not. I don't want to do that, but oh well, too bad for me. So let's look at this one. I was hoping that was on a part of that, but it wasn't. What I'm talking about is the type of sampling. Oh, yeah. You can't really see all that. Can you? Cooperate. Don't watch. You might get sick.
The sampling were the random, the systematic, stratified.
Exactly. I love it. So a woman in the airport, so looking at part A. A woman in the airport saying our questionnaires travel is asking to evaluate the airport service. She does not ask travelers who are hurrying through the airport with their hands full of luggage. She instead asks all travelers who are sitting near gates and not taking naps.
Convenience.
Is it random? Why not?
It's excluding rush.
There's a whole bunch of groups of people that can't be a part of her sample. So what is it then?
Convenience.
Beautiful. It's obviously convenient. In fact, they worded it to be like, come on, people, this is convenient. It's very convenient. You're not taking a nap. They're not in a hurry. It's very easy for her to talk to them. It's totally convenience. And do you see how that would possibly skew? She's trying to see, to evaluate the airport service. If there are travelers who are hurrying, what's one reason they might be hurrying? Because the service sucked, possibly, right? They were held up because they were kind of silly back there and they were doing other crap, and maybe they would have some choice words to say, and that would bring her data in a certain direction. Excluding them, she doesn't get that. So the data is biased away from that. So anytime you exclude groups of people, your data is almost always going to be biased in some way, or we have to assume it could be. Even if it's perfect data, we have to assume it's crap. A teacher wants to know if her students are doing homework, so she randomly selects rows 2 and 5 and then calls on all students in those rows, blah, blah, blah.
Cluster.
Beautiful. Clusters where I take entire groups and then I leave out all the other groups. Stratified is when I take some from each. Clusters is when I take all from some. I like it. Okay. Okay. The marketing manager for a chain store wants information about the ages of its customers over the next 2 weeks at each store location. 100 randomly selected customers are given questionnaires to fill out, asking for information about blah. Who cares?
Random sample.
Yeah, it sounds pretty good. What's the one thing they didn't reference, though? They really tried to go overboard with making sure it was understood, but what's one thing they maybe left out here to make it even more in your face that it's random? What was wrong with me if instead of just picking you as a sample, if I go to every classroom right now and pick people from every classroom? Yeah, time of day. So I don't know, are they taking it throughout the day? Or are they doing it at everybody before you go on break? That's a certain time of day, right? They got to do it throughout, right? But they're really trying to push that it's random. Are you guys understand? Normally it's stratified and cluster that give people trouble. They haven't given us systematic, so let's see if the next one's systematic. The librarian wants to report. What the hell is this? Wants to join a proportion of library users are children. The librarian has a tally sheet on which she marks whether books are checked out by an adult or a child. She records this data for every fourth patron. There it is. Yes! It almost had to be. Process of elimination. They got it.
What was A again?
What was A again? Oh, convenience, because it definitely wasn't random because she was leaving groups of people out. And normally that kind of hints that it might be convenience. So if I don't talk to people because I can't, let me give you an example. You ready? Yeah. Do you have a question?
It's not about that one. It's about C.
Oh, sure. Go ahead.
Well, could you argue that it's stratified because they're taking some customers from all the store locations?
The book says strategy.
Over the next 2 weeks at each store location. Oh, sure. Yeah, that's even better. So that one should be stratified. At each store location, they pick some from each. Beautiful. So that's stratified. Thank you. Cool. I like it. What was I going to say? A few years ago, I taught stats during intersession, believe it or not. It was 3 weeks of stats. Oh, yeah. And somebody said that cluster sampling was bad. And they were actually a veteran. They had been in the Iraq War. And the reason they said that is because they were going to go in soon after Baghdad fell, and they were going to go in and see what different parts of Iraq, how they were doing, what the neighborhoods were like. So they took Iraq and they broke it up into groups, and then they were supposed to randomly select areas and then go and ask people what it was like. The problem was they chose only the areas that they knew were safe because they didn't want to go where it was not safe. So this is true, by the way. This is real. This happened. So my student was like, cluster sucks because this happened. I'm like, let me investigate that. So I went and looked it up, and sure enough, that's what was wrong. So that would be an example of convenience. They didn't allow the not safe people areas to be included, right? So it sort of sounds like they were trying for it to be cluster, but it was convenience because it was more convenient to not go to the not safe place. But then automatically your study is crap. If you don't go to the not safe places and you say, well, everywhere we went to was great, that's you wasted time.
So you get biased information.
Totally, it's completely biased. That one's like really directly biased. It goes totally against what you're trying to say. Yeah, good. All right. So you see how that's convenience normally is when you're leaving groups out. There's a reason you're doing that. It's because it's more convenient, or you feel like you won't die, which is convenient, right? Okay. All right. So how are we doing that? I mean, that's a lot of terminology, but they're not like really difficult terms to understand what they mean. Okay. So we're going to get into some more new stuff, and thankfully this is not really just straight up definitions. It's actually looking at data. Boop. I'm not sure how to do this, and so many people don't have one. So, who needs a calculator? All right, so Jeff, there you go. All right. So you guys share amongst yourselves.
We'll share one.
Good. Do you want? So these are surrounded with one. All right, good. So you can share with in there. You need one? Maybe you guys. All right. You guys? You there? Or you need one too? Let's see if this is. All four of you guys. Oh boy. Let me see if I can. Maybe I'll have one up there. You guys will share one. You two here to share one. Oh, good. Yay. You need one? And you need one? And you, okay, you guys can share. And I got one left. Look at that. That's crazy. All right, so everybody should be, what's up? No. And let me show you this here. How many of you guys have Android phones? A few of you guys. All right. The rest of you, you can have fun with Siri. If you go to my website on your phone, there's a free TI graphing calculator software. So on my phone, I've got the TI-84 on my phone. It's just a little app that I pull up. That's actually, well, I don't want to make it sound more awesome, but it was up on the Play Store for a while, and then TI filed a lawsuit, and they took it down, but I grabbed it before they took it down, so, yeah, Jeff. Yeah. So if you go to jail, just, no, I'm joking. No. They had it out there, so now it's out there, so screw it. You with me? So if you want to, you can grab it. Now, obviously, you can't use your phone on a test, so don't get all too excited. Right? Your phone has way too much access to other stuff. But at least you would have a calculator for use at home. Some of you guys have got to get a calculator, because I'm not going to have enough for test day for everybody that currently does not have one. Yes?
How long you can rent them out from the library?
Yes.
Is there time limit?
How long is it?
A week.
There you go. Cool. And don't forget, you can rent them for like $9 a month from that rentcalculators.org or whatever it is. Cool. Screw me. Wait, the last time I checked it, it did. Shoot.
When do we officially need a calculator, like what chapter?
Now,
Nice.
there, look. It working for me. So see if it's still, yeah, it's $9 for a TI-83, which is perfectly fine. Pay $1 more for the same calculator, basically. It's just got a bigger number on it. It's really basically true. All right. Yay. Okay. So let's see what's going on here. So what I want to show you is some very. You just went right past it, Jeff. Good job, buddy. Came full circle. Yay. Okay. The most basic thing your calculator can do for you as far related to data is sort data. So I am not going to give you like 1,000 bits of data on a test. Right, that would be, those jobs, summer jobs they have, make money from your home. Very often they're data entry jobs. Some of them are data entry, because that's the most brainless, just 45, So, yeah. So we're going to get to experience that in here, I bet, because part of statistics is freaking bean counting, actually putting the data in somewhere. So let's do this. I'm going to make some data up. We're going to do this together, and then I've got a couple handouts that I stole from your information. I have all the heights of the moms and all the heights of the dads that people put in, and you're going to be analyzing those. Yes? This is the end, this is like part of 1.3, but then it really is used in section 2.1 and 2.2, or really just 2.2. So right now, I'm going to do 1.3 and 2.2, and then we're going to come back and do 2.1. Because 2.1 is relatively easy. And by the way, at 12, we're going to take a little field trip. Okay, I think I told you guys about that, right? Yeah. We're going to see dinosaurs and shit. Well, if you're on something, who knows what you're going to see. But the rest of us are going to just see people in rooms and stuff. Okay, so let me make up some data. So let's say this is, I don't feel creative. So this is, who knows what this is?
All right. Let's see, how much data is that? That's fine. That's fine.
So I'm taking in the school to have the same number.
Yes, of course. Because this data could be ages of people. So you don't walk into a room and suddenly age a year because somebody else is already your age. That would be freaky. I was already 25. Oh my God, I'm 26. So in general, in fact, we're going to find out that to truly do sampling, you have to allow for even picking the same person twice. Right? You have to do something what's called with replacement. You don't pick somebody and take him out. You can pick the same person several times over. And that's really how true statistics works, believe it or not. So we'll get there. All right. So the very first thing, let's just see how the calculator... Now, this is not a very long list of data. Right? And actually, let me go ahead and talk about... I'll just be a great teacher and talk about something else entirely for a second. Let's go ahead and bang Section 2.1 out, because it's quick. Section 2.1 talks about something called stem and leaf plots. They might call it stem plots. I can't remember. Let's see what they call it. Stem and leaf. Yay! I like it. Bar graphs you should understand by now. Everybody has been exposed to the idea of bar graphs. Right? Or maybe not. We'll talk about it maybe. Stem and leaf plot. Here, what the hell? You gotta love the name. What's the smallest number up there right now?
12.
Looks to be 12. What's the biggest number up there? 40 something. So
45.
cool. So 40 something. So for this data, and notice how there's a lot of repeats with a 1 first, and there's repeats with a 2 first. So that's what stem means. And then the leaves are the second digit that come off of those stems. So I have a stem of 1 and a stem of 2 and 3 and 4. Let me stop right there for a second. So what would go here, for example, I can kind of, so 2, that means 12. 8, 7, and 9. So that means 12, 18, 17, 19. Are you with me? It's very simple, but it actually is quick. I mean, now it would be easy to put it in order, right? I mean, all I have to do is pop, and then the teens are in order, for example. So 20, where am I at? 22. Is that all I have? 25 and 25 and 28. And then 30, 9, 7, where are you at, Jeff? 6, 9. Oh, I'm making this a really, too bad, Jeff. You made it really boring. 42, 5, 1, and 0. Well, that is just about as boring as you could possibly be. Thanks for agreeing so quickly. Normally what you could determine here is like if 1 was like way out there, you'd say, oh, most people are in there.